What if I take a device like this, add MagSafe magnets to it, and then combine them together so I can just keep it on the back of my phone and just carry it with me, and that could solve this problem of forgetting it at home. Mesh networking is a pretty niche community as of today. Since I got introduced to this whole Meshtastic and Mesh Core communities, I've been pretty intrigued about how these devices work, making my custom solutions for it, and that's where my whole journey of building off-grid devices as a company that solved a very specific problem originated from. Okay, this video is sponsored by PCBWay, but more on them later. Let me first explain to you what Meshtastic and Mesh Core is. I'm just throwing these terminologies out, but I understand not everyone knows what those are. Meshtastic and Mesh Core are these frameworks that work on a technology called LoRa, L-O-R-A, which means long range. Let's say your friend lives a state away, and in the middle there's a bunch of other people you don't know, but they also have the same device. What happens is your message hops over to their devices and gets to your friend who's in the other state. But those people in the middle cannot see your messages. Now, in the beginning, I was not very much into 3D designing custom solutions, so I was still very new to it. So I tested a bunch of different solutions from the internet where it would take the big rack board and then the giant antenna on top. I've tried this and used this as my main thing, but it pretty much sits on my desk all the time. I've had these smaller nodes that I printed online, and these have been working fine. I've actually not used this one in a while, but the design online are pretty reasonable and they work fairly fine. But this is a totally separate device that you have to carry with yourself, and having your phone on you if you're leaving your home, so with keys and your wallet. And if you're into this sort of a niche product, you want to take it with you everywhere to find new nodes and like connect with other people, you kind of forget this at home. So that was the original problem I wanted to solve, is how do I remember to take this with me wherever I go? Now, one thing I never forget is taking my wallet. So that's where my whole journey began on creating a device that has magnets inside of it. Now, over the past 5-ish months, I've gone through a bunch of different magnet suppliers, finding like Amazon solutions, figuring out how in 3D prints, adding a magnet in the middle of a print and then attaching it to your phone. The beginning few of them were not very strong magnets at all, and that gave me a lot of feedback from customers asking for, could we get a stronger magnet, because that was a product category that people did really like carrying with them, but not having a strong magnet was a big issue. Then the third problem that people had was a lot of people like to change antennas on it. This is, I think, a 2 dBi antenna, and this is the one that I was including with the first orders, just the default one that comes in. It works great, but it was not the best solution. So people like to buy this antenna from MusicWorks to increase the range of it. Now, it's pretty hot swappable, but the original issue with the first device that I was selling was you cannot power it down. Once I assemble it and I ship it, you literally cannot power it down unless and until you take the batteries out, and for that you need to unscrew the whole thing and take everything out. And that was just not a thing that was possible. Even I found that to be a lot of work. I needed to figure out how can I add a power button in the same footprint so that people can just power it off and then add an antenna on top. Coming to the fourth one is a customer asked if on the rack boards there's this reset button, and if you hit it twice, it puts it into bootloader mode, and then you can connect to your computer and you can flash Meshtastic or Mesh Core or any other framework on it. But the design that I was shipping, you had to take a SIM card ejector tool and then you could hit it twice, but then you have to figure out where your SIM card ejector tool is. And problem number 5 was there's this LED indicator on the board that tells you when it's charging and when it's not. It's just a red LED light. And because if someone bought the white colored case, the LED would come through the case, you could see the light glowing, but if someone bought a black color, the LED would just not pass through it. And I know you can see that it's charging, but it's a good thing to see when the charging indicator says that it's charging. It's just those little visual cues that are very helpful. The sixth is something I wanted to do was, could I fit a bigger battery in there? As of the first device, I was including a 1800 mAh power battery, so that would last about a week, if not a little more. If you're in a much denser area and you're just like discovering more nodes and the public channels are very active, you would drain the battery a lot faster, about like 4 to 5 days. So I wanted to see if I could do a much bigger battery. And the seventh and the last thing is durability. Someone's gonna drop their device. So figuring out a case design that will be strong enough that if you drop it on concrete, it won't just crack, because the whole point of this device is taking it outside and using it. A lot of devices that you'll buy from Amazon or Etsy are printed with PETG or PLA, and they're not really made to be in sunlight. And those plastics will soften over time and your device will not be very usable. So I had to figure out a material that fixes a lot of the design quality and getting the durability built into the case. And this was a big design challenge to figure out how to fit a battery, a on-off switch, a stronger magnet, which is going to be thicker than the previous magnets, and getting it all into an enclosure that is much stronger than before. Now, before any of this design could happen, I had to first figure out what electronics are going inside the device. There are two options that the Meshtastic community uses, and I wanted to test them both. The first one I tried was the Heltec V4, and that's the much cheaper alternative to the rack board. So that's the first one that I tried to design an enclosure around. The problem with the Heltec device was it's just too long. The dimensions just do not work in a device that's constrained with the dimensions of your phone. It's gonna go in the back of your phone. It cannot be too long because there's also gonna be a battery in there. So I went back to the rack whisk block to use in the final device. That just was the right choice for this form factor. Okay, let's start with solving problem number one. How do we get a much stronger magnet than previous, and while keeping the same exact dimensions and not making the device thicker? Finding the right magnet supplier was harder than you would think. I started off with finding solutions on Amazon, so I found this fairly cheap but still pretty expensive metal rings. And you can put these metal rings on top of the device and think, okay, this should be strong enough for the phone magnets to attach the device with, but actually it is not strong whatsoever. So I actually needed actual magnets, not just a metal ring inside the device. So I found certain other solutions on Amazon. I'll put them on the screen right here. And while it works better than just a metal ring, this magnet is added halfway through the print. So there is a layer of plastic, which is about 0.25 millimeters, which is quarter of a millimeter. Doesn't sound like a lot, but it is a lot for a weak magnet. So after shipping a bunch of those, this magnet was not strong enough. So I had to go out and find other suppliers. So I really had to dig deep, and I finally found a supplier that got me these ring magnets. And I actually bought a stack of like, I think 60 to 80 magnets, and I've actually shipped a bunch of devices, so I've used a lot of them. So each one of these magnets are about 1.5 millimeters thick, so they're still pretty slim, but then I could now put this in the middle of a print, so these magnets are not exposed outside, so they would damage the back of your phone because it is still a metal, so it would scratch your phone. Plus they would come off the device over time with a lot of use, so I had to embed it inside the plastic. So there would be a 0.25 millimeter layer of plastic, then this, and then the rest of the device with all of the battery and board. So when it connects to the phone, this magnet is much stronger. So this is what I was using in Beacon 1, the first device. But as the improvements had to be made, I really wanted to make this even stronger. And this is a magnet that's specified in Apple documentation on the Neo Dim magnets that they actually put it in all iPhones. And this is the same exact magnet, but I needed it to be a little thicker than this one specifically. So I went out and contacted the supplier and found that they actually had a 2.5 millimeter magnet, which is the exact same as this, but 1 millimeter thicker. So that does mean that it's gonna be even stronger. And here it is. This is much thicker than that previous one.
Damn, boy, he's thick, boy!
If two of these actually stick together, it's very hard to separate them. You might not even see it on camera, but this is 2.5 millimeters thick, much stronger magnet than this one. But now that I'm increasing the thickness of the magnet by 1 millimeter, the device is also gonna get thicker by 1 millimeter. So I had to find ways where the thickness of the device does not go up whatsoever. And let me show you how I actually achieved it. This is version number 1. You can't see the magnets in here. This is the base. This is what connects to the back of your phone. But if I show you a cross section of this, as I go down, you'll see this entire hole that's inside. And when the 3D printer is printing, it actually prints from the base, goes up. And before this first layer could come up, I put the magnet in here, and then the printer goes again and puts another layer of plastic covering that magnet up, and then builds the rest of the structure. And this way the magnet is hidden here, and the magnet is hidden here, and you won't be able to see it, but the magnet exists. Okay, this is our latest version, and you already see where the magnet exists. I don't even have to create a cross section of this. This is where the magnet is. If I show you how we achieved this, the thickness of the base on the previous version was 2.5, but now it's 2.75. So I had to increase it just by a little bit. But now there is no extra plastic layer that goes above the magnet. So now the thickness of this is only 2.45 millimeters, which is about 2.5 millimeters. And that gave us the ability to put a much thicker and stronger magnet without having to increase the overall thickness and footprint of this entire base. Okay, now this was an interesting problem. Number 3, adding an on-off switch was fairly easy. All I had to figure out was which one of these switches did I need to use, because there could be a bunch of different shapes and sizes and reliability of different switches. So I just bought a assortment kit which had 9 different types of switches inside of it. So I tested a bunch of them on a breadboard, figured out which one on the data sheet from the supplier says has more reliability. Because if people are carrying it with them, I want to have it so it can be turned on and off multiple times and be durable enough and not just snap off, because there's no easy way to just replace it. So I came up with this very ingenious solution to fix this problem, where this on-off switch can just be slid into this little pocket. And as soon as it's slid in, it's still not secure whatsoever, but the height and width of it are just enough for the switch to go in, but can still slide out. But the solution to that is because then on the top we put the cover. That cover has these little ridges I created that as soon as that slides on it, it holds the switch in place with the X, Y, and Z axis. So the switch literally has no place to go unless and until the case is taken out. I didn't need any glue. I did not need to screw it in. It was just all mechanical way of securing the switch in place. Now solution number 4, creating a reset button so you don't need a SIM card ejector tool to press the reset button on the board. I actually was taking an elevator down and I saw on this emergency light that there was this button which is just extruded out of the existing outer casing, but has this little empty gap that allows the plastic to flex a little bit, and then that hits the button inside. I actually never really looked at these things that are around me that already have these solutions built into them. So I took inspiration from it directly, and I knew that this was actually gonna work for me. And then I went into my CAD modeling tool and just started designing it. So after designing it, after tuning it a lot and making sure the part is still strong enough that it doesn't break, I actually got the perfect button click sound without needing a SIM card ejector tool. For solution number 5, this was the easiest out of all of them, because all I had to do was project the light of the charging indicator onto the case and just cut out a little hole that is not too big and get that hole perfectly carved out so you can easily see the LED light coming through. And doesn't matter what color case it is, the LED will always come through it. Now solving problem number 6. This was a little tougher than the other ones, because now I had to figure out how do I fit a battery, which was first much smaller and easier to fit inside the case. But in the second one, going from an 1800 milliamp hour battery to a 3000 milliamp hour battery, which is about 40% more battery, that was a big challenge. Now the readily available batteries that I bought, I could not put it in the same orientation like the first version. Now I did find a perfect orientation for this battery, so it can go landscape instead of being vertical from the first version. Even the base model iPhone 17 had the dimensions so that the width of this device with the bigger battery would not exceed the width of the phone, so it would not be uncomfortable to hold whatsoever. So it was a very slight trade-off for a much longer battery life. Okay, now solution number 7. PLA is very soft and can be brittle, so it's not very durable material, and PETG is good, but printing with it can have its own challenges and is not as durable if you're taking it outside in the sun, and it can soften over time. So it's not the best material. So what I ended up going with was ASA. The print quality got really good, it got more durable, but I still had the little issue of there was no great orientation to print a cover like this, where if I print it this way, it's gonna have those rough edges in the corner, but if you're holding the device like this, it's just not a good feeling, so you need this to be smooth. So for this to be smooth, it needs to be standing up. But if I print it standing up, while it takes longer, which is a fine trade-off, you will still have these supports at the very bottom of this because it curves up and the filament needs to go somewhere. And then that leaves these rough edges, and those rough edges just have no great way of going away. Look at these rough edges. These just don't look good whatsoever, and these are the supports that I took off. I've tried a lot of different ways to maybe sand the corners and then take a lighter and like melt the plastic at the very top so it melts and fuses to look as good as the other edges, but it just never comes out to be a perfect corner like you would want it to be. And at that same time, PCBWay reached out if I was working on a project that they could actually sponsor. And I told them this was the perfect time that they could have possibly reached out because I needed someone with that kind of engineering experience and the materials that they had to get me a design of the final device that would be actually like a production quality product. So we actually landed on a filament type called Nylon, and to be specific, it's called MJF Nylon PA12, polyamide 12. That is a mouthful, and I don't know how to say it. But it's printed on an HP multi-jet fusion printer, which puts a layer of powder, solidifies it using light, and then puts another layer, and it does that for a very long time instead of putting layers of plastic and going up. So after waiting for a couple weeks and going back and forth with them, I actually received this design right here. On first glance, I thought this was gonna be like a very brittle, like it's very not solid, it's gonna maybe break. But the more I looked into it, this exact thing is much more durable than the ASA one. And look at this. It is a matte finish compared to this shiny. Now, some people may prefer this shiny one, but I really like this matte finish. And if I am holding this device in my hand, and this is a fully built device with this exact case, it actually feels really good. I was actually really surprised on how good this actually came out. Now, the one and only downside of this case is the UV protection. A lot of people print with ASA filament just so they can have a product that can be outside in the sun all the time. I actually printed these plant hanging things for my wife, and she has these very heavy plants with all the soil in there, and it's just hanging from these ASA prints that I made. They've been out in the sun in June right now, and they haven't softened, they haven't moved at all, but that's for actual things that are gonna be outside in the sun all the time. But a product like this, you're carrying it out with you, you take it home, you charge it, it doesn't just sit in sunshine. This is still much stronger and more UV protectant than a PETG or PLA print, but not as much as an ASA, but this is also not meant to be out in the sun 24/7 all year round. And one of the biggest things to solve with this case after durability were the corners, and this is on the new nylon printed. Look at these corners. Look at this one. This is much better on my right than this left one. And these are just the corners that I have not been able to solve on a 3D printer, and this is what I got from PCBWay. This has been a much longer video than all my previous ones. I just wanted to take my time and show you what it takes to make a product that goes from something that people like but had a lot of feedback and actually implementing it, testing it, trying different variations to address all of them into one product. Now, if you're interested in buying one of these, I will leave a link to that in the video description below. And if there are still things that you think that you would want in a future version of this, let me know in the comments. Let's talk about it. What are some problems that you may have with your Meshtastic devices that you're using and you would like solved? And if you watched this video till the end, I'm very much appreciated. I would love to hear what your thoughts are on this video, any feedback that you may have, and I will catch you in the next one. Thank you for watching.